So we're going to look at tangent lines today. Oops, I want a prettier color.
Is this how you record your videos?
Mm-hmm. And so these are notes 10-5. So as you can see here, we've got a radius, and we have this tangent line, and we talked about tangent lines when we did definitions. And so we know that this is a tangent line because it touches the circle how many times? Once and only once. So it just kisses the outside of that circle. And then this point at which it touches the circle is called that point of tangency. And whenever you have a radius that touches the point of tangency, you always have a right angle there. So it's one thing that you're going to have to get in the habit of doing is anytime that you see a radius connected to the point of tangency and that tangent line, there's always a right angle there. So let's look at the information over here. So a tangent line intersects a circle at exactly one point, called the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius. Thank you. Drawn to the point of tangency. And so if you happen to see a picture that looks like this right here, where you see some line touching the circle in one place and you see a radius touching what appears to be a point of tangency, and they tell you that there's a right angle there, you can assume that line AB is a tangent line. And so that's all that this is saying. But vice versa, if they didn't have the right angle there, you can assume that if a line appears to be tangent, it is, and if a radius is going to that point of tangency, you have that right angle. So let's look at some problems. So question 1, we're to determine if line segment AB is tangent to the circle at P. So if I want to determine if this line segment AB is tangent to the circle, I have to make sure that right there, that would be a right angle. If that's a right angle, then shouldn't the sides of this triangle that they've given me match Pythagoras' theorem? And so you're going to have to apply Pythagoras' theorem and see if it's true. If it doesn't hold true, then line segment AB is not a tangent line, and A would not be a point of tangency. So we're going to start with A squared plus B squared equals C squared. So what is my hypotenuse? 17. And you guys have calculators on your desks. And so you can put the 8 and 15 wherever you want to. Thank you, Sophie.
What is that?
Right there. Yeah. So tell me what, as I'm losing my voice, tell me what 8 squared is? 64. What is 15 squared? More than just one of you. And then please plug in 17 squared and tell me what you get. What do you get? 289. What is 64 plus 225? So 289 does indeed equal 289. Isn't that a check? So yes. Segment AB is tangent to circle P. I'm just going to put the notation circle P. Mm-hmm. All right, so then you would do the same thing for question 2. We're not going to look at that for right now, but you would do the same thing. And I'll tell you right now that question 2 does not turn out to be equal. So you have to check it. You can't assume that with this type of question that it's true. All right, so then let's look at question 3. The directions say, if line segment JK is tangent to circle L, find X. So as you look at this right here, they're telling you that's a tangent line. So what do you know about this right here? Because that's what? What is this part? It's a radius. So when a radius touches a point of tangency, what do you know about angle J? It's a right angle. So immediately, you should put in there your right angle. Then how are you going to find X? Good, Sam. So we're going to use Pythagoras theorem again. It's going to become important today. Oh, that's a terrible C. Alright, so I've got something squared plus something squared equals something squared. What's my hypotenuse? X. So X goes on one side by itself, and it doesn't matter where you put the 7 and the 19. So what is 7 squared? 49. Please tell me what 19 squared is. 361. Is that correct? Okay. And then X squared, right? So what is 49 and 361?
14.
Now at this point, how are you going to find X? You're going to take the square root of both sides. Now they haven't mentioned rounding, right? I'll be very clear on my test whether you can round or not, but it would technically I would assume that you would give me the exact answer. But go ahead and take 410, put in your calculator, and find the square root. And then I want you to round to 1 decimal place. What is X approximately? 20 point what?
2.
Everybody agree with that? Okay. So that is the answer that they're looking for, right? Okay. Then I want you to find X and number 4 on your own. You can do that on your paper and or your whiteboard. It's your choice. Paper or your whiteboard. Let's talk about something for a minute. Is there an issue here? What's the issue?
The 7 is supposed to be the hypotenuse, but
You don't have all the hypotenuse. So the hypotenuse, it's because some of you went and put 7 squared here, right? And so when you had 121 here, you're like, there's no way that this can be right. There's no way the hypotenuse can be 7. Well, the hypotenuse isn't 7. Isn't 7 from here to here? So be really careful with those. What are we going to call this, or what is this? What is it? What part of the circle is it? It's a radius. And that means it's 11. Aren't all the radii the same in the circle? So if this is a radius and that's 11, so then this is 11 also. Does that help? Now what's your hypotenuse? 18. So now continue. Oops. Round to 1 decimal place, what do you get for X? What do you get? 14.2. Alright, so you might want to star that because that's one that'll trip you up easily if you forget that all the radii are the same. So I would just like highlight that or something, right? Because it's a harder one. Alright, so then look at number 5. Let's talk about number 5. Talk about your table group. Don't solve it yet, because if you try to solve it, you might do it wrong. But just take a minute and talk in your table group. How is 4 and 5 alike? How could you solve it? How could you make it easier to solve? Alec, you're not solving it. You're discussing in your group. No, not just the two of you. You've got 2 beautiful young ladies there who would like to chat as well. Okay, so what are some thoughts? What are some thoughts? Everett, what did you guys come up with? Okay, so like number 4, x is only part of the hypotenuse, correct? What's the rest of it?
You solve it this way, doing 10 squared plus 24 squared equals x plus 10 squared.
Okay, so he is saying that this missing part is 10. Would you all agree? And he's saying that we could do 24 squared. This is the harder way, by the way, so I wouldn't suggest you do it this way, and I'll explain in an easier way in a minute. So he's saying, and not incorrectly, 24 squared plus 10 squared, because that's one of the legs, is equal to the quantity x plus 10 squared, right? Is there any issue when you guys square this? What's the common error? X squared plus 100, and that's not what it is, right? So remember, these have a middle term, and so we could do it that way. It would require factoring knowledge, and do y'all want to factor? Who wants to factor this? Raise your hand. I don't see a hand going up. Oh, I'm the only one who wants to factor. So this is the harder way. I propose instead that you let the hypotenuse be y. Just the whole hypotenuse be y. So that instead of the 24 squared plus 10 squared, you're going to keep that. But instead of this, can't we replace this with y squared? Do you see what I'm doing? So instead, we're going to have 24 squared plus 10 squared, and you tell me how easy or hard this math is equal to y squared. So what's 24 squared? Punch it out. 576. Plus, what's 10 squared? My writing is so horrible. Equals y squared. Add those together, you get 676 is equal to y squared. Then how do you solve for y? Take the square root. And what does y equal?
26.
What is it?
26.
Exactly 26, isn't it? But we don't want y. What do we want? Okay, so y is equal to x plus 10. And we know that y is 26. So what does x equal? 16. Just subtract 10. Wasn't that easier than having to factor? So if I were you, I would put here, this is the hard way. You could do it that way, but it's a hard way. It's so much easier to make mistakes that way, bless you. And I myself will start trying to solve it that way because I'm just used to doing that, but I'm comfortable with factoring. But it's so much easier and so much quicker if you solve this problem this way. Okay, so look at number 6. What's wrong with 6? What are we missing? Half of what? Yeah, so we're missing ML. What's ML? 11. So I'd put mark in there that that's 11. Where is our right angle? At J, right? So we need to put a right angle marker there. And so if we were to find x, and we're getting ready to use Pythagoras' theorem, what is our hypotenuse? So the 25 would go here. What are my two legs? What's this whole leg? 11 plus 11 is 22, right? So one leg's 22 and one leg is x. So we're going to put 22 here and then x here. So tell me what 22 squared is. 484 plus x squared equals 25 squared is 625, right? So subtract 484 from 625, what do you get? 141, and then now take your square root of both sides. What is x to the nearest tenth? 11.9. Does that answer the question?
Yes.
Yep. That's a really sad 9. There we go. Okay. So all these problems are kind of different from each other, so I'm going through a lot of them with you today on purpose. All right, so let's look at 7. So where's my right angle on 7? Again at J, right? So I'm going to put my right angle there. Do I know my entire leg from here to here? Well, if that's 3.5, what's that? Yeah, so that's 3.5, and you're right, the whole thing's 7. And then isn't this pretty much just like number 6, except for our hypotenuse is x squared? Do we need to solve this? Are you okay with solving this by yourself? Right, you could do that on your own. Okay, so let's skip 7. Let's go to 8. Where is the right angle on 8? Again at J. Now this one's a little bit more complicated. What's this missing piece here? X. So you got to put x here. And then we're going to do a squared plus b squared equals c squared. What's my hypotenuse? 25. So 25 goes in here by itself. This leg is 7, right? So 7 goes in here. What's the other leg? The question is it's either x squared or it's either 2x. Which is it? When you go x plus x, don't you get 2 x's? It's only x times x, so you get an x squared. So be really careful that you're putting a 2x in for your leg. So the other leg is 2x. You have to square both the 2 and the x. So when you square them, you get 49 plus 4x squared equals 625. Subtract the 49, what do you get? You get what? Did we? Oh, yeah, I guess we did. Okay. No. Let me see your calculator. So we get 625 minus 44, or sorry, 49. Huh, I didn't believe you, but yeah, it's 576. And then divide by 4. So we're going to divide this by 4. And we get x squared is equal to what? Is it 144 or 114? Oh, okay. And then when you take the square root of both sides, what'd you get? Yep, so x is equal to 12. And does that solve the question? Okay, so how else could you have done this particular problem differently? Could we have done something different here rather than x plus x is 2x? Sam? Yeah, we could have let that whole value be y. You do run a risk, right? So if you let the whole value be y, you would have had just a y squared, and then down here you would have had y squared equals 576. Please find the square root of 576. 24. So your y would have come out to be 24, but I'm looking for x. You would have had to remember that, y is equal to 2x. You would have had to remember to divide by 2. So there is a danger in this particular one letting that be y, just like there's a danger in, this one here, number 5. So just like there's a danger here is when you solve for y, you forget to subtract 10 from the value. So whenever you assign y to something and you're really trying to find x, just don't forget, what am I solving for? Okay, so any questions on the front? All right, so let's flip it to the back. So number 9, we can't avoid talking about. What are we missing on our picture? Yeah, what is this distance from here to here? What's that distance? Yeah, if that radius is x, this radius is x. So we're going to put an x here. So if we set up our a squared plus b squared equals c squared, where is our right angle? At J again. So if that's my right angle, is where is my hypotenuse? Yeah, LK. What would you call that hypotenuse? Is that 10K? Is that X, or what did I say, 10K? Is that 10X, or is that X plus 10? What is that? X plus 10, you're adding. So from here to here, add the pieces together. It has to be X plus 10. It's not 10X. And so if we put X plus 10 in here, we're back to that situation on number 8, or which one was it? Number 5, right? Which we're going to have to talk about. Can we swap that out? Your legs are X and 20. If we let this be Y, is that going to be an issue? If you put Y in the equation, what's the issue? There's 2 variables. So that's the problem. So unlike number 5, I can't let this distance be Y. We're going to have to square that binomial. So again, what's the common error here? What do a lot of kids say that this product is going to be? X squared plus 100. And you know it's not, right? So we're going to actually write it out. So we've got x squared plus 20 squared is 400 equals, and we're going to actually multiply out x plus 10 times x plus 10. So we get x squared plus 400 equals, FOIL this out, x times x is x squared. X times 10 is 10x. Distribute the 10. 10 times x is 10x. And 10 times 10 is 100. Collecting like terms, we've got x squared plus 400 equals, and then here we have x squared plus 20x, and all I'm doing is collecting my like terms here and here, and then plus 100. What's the first goal I should have? What was that?
Get your variable.
I want to collect my variables together, but what's my highest degree variable? X squared or the x's? Highest degree. X squared. So those are the ones you want to try to collect first. If I subtract an x squared from both sides, magic occurs. What happens? Yay, they cancel out. So then I'm left with 400 equals 20x plus 100. Subtract 100, I have 300 equals 20x. Divide by 20. My zeros cancel. What's 30 divided by 2? 15, right? So isn't x equal to 15? So that one turned out nicely that I didn't have to refactor at the end. So that was good.
So you don't have to plus the 10 at the end?
They're asking for just x, right?
Oh.
Yeah. Unless they ask for the length of L to K, then you would, of course, have to add the 10 to it. So just watch to see what they're asking for. In this case, all along, we've just been asking for 10. All right, so any issues with that? You see a lot of different types of problems that can crop up. Agreed? A lot of prior knowledge comes into play, too. All right, so let's look at some more different types of tangent lines and tangent issues. So we were just looking at a tangent line meeting with a radius at the point of tangency. It creates that nice right triangle. Well, that's not always what we have. So in this case, we have 2 tangent segments meeting outside the circle here at point B. If you have 2 tangent lines meeting, number one, if you were to draw a radius to those points of tangencies, you could actually end up making 2 congruent right triangles. And the reason why I say they're congruent is because these tangent segments here are always going to be equal to each other. So if you draw any tangent lines from a point of tangent C and they meet outside the circle, the distance from the point of tangent C to the point that they have in common are always going to be congruent. So the next one kind of uses this theory. Wouldn't from D to B and from B to E be kind of like this picture here? Agree or disagree? Just this portion right here, wouldn't it look like this picture here? So if that's the case, then I can go around, anytime I see a bunch of tangent lines, can't I say that BE is congruent to DB? Right? I can also say that EC is congruent to FC. However, notice I use double tick marks. What I can't say is that EC is congruent to BE. A point of tangent C does not split a tangent segment into two equal pieces. All it does is the place at which we have those tangent segments, if you will, whenever tangent segments meet outside the circle, the pieces from their point of tangencies are the congruent parts. So then, aren't I going to use triple tick marks here? So here I've got triple, 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 triple. So how does that look in use? So look at question number 10. What do you know about segment AB and segment CB? They are congruent. Why? Because they appear to be tangent lines. And doesn't it look like a dunce cap on somebody's head tilted sideways? Or a what? A what? Oh yeah, it could look like a bird's beak too. Yeah. Or somebody like wearing a happy birthday cap. Anyway, so we're going to set those pieces equal to each other. 5x plus 23 is exactly equal to 8x minus 19. You solve that yourself. I'm going to quietly do it up here. You solve it yourself. Did you get 14 for x? How could you check to see if you're right? Plug it in and make sure that both AB is congruent to CB. Isn't number 11 identical? Okay, so we're skipping that one. Woohoo! All right, so then number 12, doesn't number 12 look like what I did to this right here? See how I added in the red line? Isn't that what number 12 looks like? So for number 12, you want to put in, it's a kind of combination of the front page and the back page. Don't you have a radius here with a tangent line, tangent segment? Where are the right angles? At T, and there's one at U, isn't there? And I know that these are congruent right triangles because of the theorem above. I know that these two segments are equal, and they share a hypotenuse. Those segments are equal. So by HL, aren't the triangles congruent? Okay. So the question is find the distance from S to V. So we eventually want to find this distance here. What would we need to find that distance? If I knew the length from S to T, like the actual length, and I already know this length is 17, can't I use Pythagoras' theorem then to find this hypotenuse that they share? So that's what we're going to do. So this is a multi-step process. So step 1, we are going to use our theorem above, and we're going to state that 10x minus the 41 is exactly equal to 4x plus 7. How do I know to start there? That's what they gave me. Question.
If you really want to, couldn't you also use
You could, assuming that x turns out to be a nice, pretty number, but I don't know an angle. I just know sides, and really, SOHCAHTOA is not going to help me if I don't know an angle. I could find the angle. That's a lot more work, though, right? So you could. All right, so then we're going to collect our x's first. So minus 4x So I get 6x minus 41 equals 7. Add your 41. So I get 6x is equal to 48. What is x? 8. All right, so we know that x is 8. What would be our second step? Plug it in where? Does it matter which of these I would plug it into? I could use the bottom triangle. Which one's nicer to plug into? The 4x plus 7. So I'm going to use SU. So from S to U is 4x plus 7. So SU is a lovely 39, isn't it? So I'm going to put 39 out here. What's UV? 17. And then we're going to call this distance right here Y. And so step 3 is to use Pythagoras' theorem. A squared plus B squared equals C squared. So what's our hypotenuse? The Y. So I want that on one side by itself. So my Y is going to go here, and then my legs are 17 and 39. What is 17 squared? 289. What is 39 squared? What is it? 1521 equals Y squared. Add those together, what do you get? 1000 what? 810 equals Y squared. Now how do you find Y? Thank goodness you have calculators, right? Is that going to answer our question? No. So then what does Y equal? What is it? 42.1? Oh, thanks. Doesn't that actually answer our question, though? Isn't that what Y is? Aren't we trying to find SV right here? So isn't S to V what we called Y? So actually, that is the answer to our question. So therefore, step 4, SV is approximately equal to 42.5. All right, 13 and 14 deal with the last theorem that we had up there. So they give you a few pieces of information. They give you that this is 11 here from here to here, this is 16, and this is 9.5. All you have to do is look and say, okay, if this is 11, don't we know that this piece is congruent to that piece? Right? So if that's 11, from D to H is 11. If from H to E is 16, what's from E to I? 16. If from F to I is 9.5, what's from G to F? 9.5. How do you find perimeter of something? So we're going to take, and can't I just do 2 times 11 plus 2 times 16? This is going to be my perimeter. Plus 2 times 9.5. Tell me what you get. Nope, you're off one. 73. So that's easy. 14 is a little bit more difficult. What's the difference between question 13 and 14? They give you this whole distance, and you can't just take this whole distance here and like split it in half and say, so what's 37.5 divided by 2? What is it? 18? Okay, so you can't put 18.75 here and 18.75 there. But here's what I can do. If this is 23 right here, isn't this 23 right here? So just this little distance from here to here is 23, because these two pieces are equal. How do I find this piece? It's kind of like a dominoes. Once you find one, you can find the other.
Subtract.
Yeah, so subtract these two values here. What's 37.5 minus 23? 14, what? 14.5. So this is 14.5. Isn't this piece here also 14.5? So we're going to put 14.5 here. And then they give you this piece here is 27.1, so isn't this piece here 27.1? So put 27.1. And then how are you going to find this piece here? So subtract these two, tell me what you get. Say it louder. 25.4, does everybody agree? Okay, so that means that this piece is 25.4. And then we have the last piece. So now go ahead and add up all the sides. So your perimeter is equal to, and this is too much to write out, but I want you to add up from here to here. You can use the longer one that they gave you if you want to for here. Add up those pieces and add up that. Tell me what you get. Oh, did you get to the homework? No, that's not it. She's doing pre-counting. We don't want that. Okay, what'd you get? I heard it. What? 180. Oops. Try this. 180.